I'm Sylvia Knight from the Royal Meteorological Society, and in this film I'd like to give you an overview of the sorts of weather measurements that you might like to include in your independent investigation. Weather measurements can be useful for all sorts of investigations, whether you're looking at more human processes or whether you're looking at physical ones. I'm going to show you a range of weather instruments in this film. Some of them are very simple, some of them are even homemade. Others are more technical instruments that you might need to borrow from someone if you're going to use them. Let's start with temperature. Digital thermometers are everywhere these days. They might even be in your phone or even in your watch. It's not hard to come across a digital thermometer for just a couple of pounds. But the same things apply to whatever sort of digital thermometer you're using. So I'll go through some of those now. I've got two types here. This one's got a probe attached to it, and this one doesn't. So if you have a thermometer like this with a probe, obviously don't touch the probe while you're measuring the temperature. On the other hand, most other thermometers are recording the temperature inside the thermometer and have a couple of little air vents to let that air in. Again, you're going to need to not touch those little holes while you're measuring the temperature, or you're going to get an incorrect reading. The precision of a digital thermometer might actually be quite small, so you might get tenths of a degree, you might even get hundredths of a degree showing. But it's worth remembering that unless you've paid a lot of money for your thermometer, it's probably only accurate to within a couple of degrees, maybe even 3 degrees. This thermometer here says 22.4 degrees at the moment, but that might actually be 24, 25 degrees, or even as low as 20 degrees. So you can use the same thermometer to take measurements in different places, but as soon as you want to compare measurements from different digital thermometers, you're going to need to calibrate them before you start using them to work out what the difference between those thermometers always is. Temperature is never measured in direct sunlight. So if I was going to measure the temperature today, I'd have to put this thermometer somewhere which is quite shady before I could measure the temperature. Traditionally, that was done using a Stevenson screen with instruments that were always left in one of those white slatted Stevenson screen boxes. But just finding somewhere shady and preferably far away from a building is probably good enough. Another thing to watch out for is that digital thermometers will always take a while to adjust to a new temperature. So if you're taking a thermometer from inside to outside, give it a few minutes before you start looking at the temperatures it's recording. And something else to watch out for is that the temperature will change with height. So on a day like today, if I was measuring the temperature near the ground or higher up, I'd get a different measurement. So if you're recording the temperature in different places, always make sure that you're recording it at the same height. Always measure the temperature at the ground or always measure it higher up. Car thermometers are another really useful type of thermometer that you might like to use, particularly if you're looking at urban climates. Almost every car has a thermometer built into it now, and that thermometer is usually in the wheel arch. So again, give the car a few minutes after it started moving, because that will allow the air to move through the wheel arch and for the thermometer to be accurately picking up the current temperature. But then again, you can usually really nicely see urban microclimates through the temperature that the car is measuring. Infrared thermometers are another great way to record the temperature. They're quite cheap, they're very robust, and they're incredibly versatile in the numbers of things that you can do with them. They work by picking up the heat that's emitted by any body and turning that into a temperature measurement. And the nice thing about that is that you haven't actually got to touch the thing that you're measuring the temperature of. It's just that the further it is away from you, the bigger it's got to be before you can measure its temperature. So something's 10 meters away from you, it's got to be 1 meter big. If something's 10 kilometers away from you, it's got to be 1 kilometer big before you can measure its temperature. So for example, on a day like today, I can use this thermometer to measure the water surface temperature. That water surface is about 15 degrees. On the other hand, the pavement temperature here has got up to 26 degrees. Or if I wanted to look up at the clouds, it's about -3 degrees today. So that would imply that cloud's actually quite warm and probably quite low. If you want to measure air temperature with them, you can't just point the thermometer at the air because it's going to pick up the heat from whatever's behind. So to measure air temperature, you just need to take a piece of white paper out with you, give it a few minutes to adjust to the temperature of the air around it, and then you can use the thermometer to measure the temperature of the piece of paper. And again, that's probably best done not in direct sunlight, so you probably want to go somewhere shady before you measure the air temperature. If you want to measure the temperature over a period of time, you can now get very simple little USB temperature data loggers, which can be left outside and which can be set to record the temperature every second or every minute over a long period of time. and then you simply just take it inside, you plug it into a computer, and you can download the data and use an Excel spreadsheet to see what it's recorded. And if you want to leave it outside, all you need is, well, we've got here a small yogurt pot. You can put the thermometer in the yogurt pot, and then it can be left outside safely, whatever the weather's doing, and you can get a nice long measurement of how the temperature changes. Humidity is another weather measurement that's got a lot easier to record over recent years. So you used to have to use a wet and dry bulb thermometer and then use a table to convert the difference between them to work out what the air humidity was. But now a lot of digital thermometers will also tell you what the humidity is. Here I've got a simple weather station which has got the temperature and the humidity, which is down to 55%, which is actually quite low. It's nice and dry here today. Rainfall is another weather measurement that's very easy to make. You might have access to a simple weather station which has got an inbuilt digital recorder to record how much it's raining. But if you don't, there are very simple rain gauges that you can use that will give you accurate measurements. This one just has a cylinder inside which has a scale on it, which you can read off at about the same time each day to see how much it's rained over the last day. If you had something like this, you'd probably want to bury it either in the ground a little bit or maybe in a plant pot full of sand or soil just to stop it blowing over in the wind. But even if you don't have a rain gauge like this, it's very easy to make a functional rain gauge. So here I've just taken an empty fizzy drink bottle, cut the top off, put the top back in, inverted, and then again, it'll just collect the rainfall. You probably want to bury it in something to stop it blowing over, and then you can come each day and probably tip the water out into a measuring cylinder so that you can get an accurate measurement of how much it's rained. With something like this, you'll need to convert the millilitres of rainfall it's collected into a millimetre depth of rainfall, because you'll need to take into account the width of your bottle and the kind of area over which it's collecting that rainfall. Something to watch out for with all rain gauges is to make sure that they've not got spiders' webs in them or slugs in them or anything else which might be affecting your data. Air pressure is something else that you might like to record. Air pressure is easy because there don't tend to be small-scale variations in air pressure. So the air pressure in one place is very likely to be the same as somewhere a few kilometres or even tens of kilometres away, particularly on a calm day. So whether you're measuring the air pressure inside or outside, or even if you don't have your own instrument to measure air pressure and you just want to use the pressure from some published weather stations somewhere nearby, chances are that's going to give you the same value, and that's fine to use. Here we have a simple weather station and it's recording the pressure. Today the atmospheric pressure is about 1,015 millibars here, so it's quite high pressure today. But the thing to note is that air pressure is always reported at sea level, so as if you were at sea level. So if you're high up, it's corrected down to what the sea level value would be. On the whole, atmospheric pressure falls by about 1 millibar, 1 hectopascal for each 10 metres in altitude. So that's something you're going to need to take into account if you're measuring air pressure. Air pressure doesn't tend to vary very much with place unless it's a really windy day, but it will vary with altitude. And so you need to be careful to make sure that you're at the same altitude as the measurement that you're using. If you're using data that you've got from the web, maybe from somebody else's weather station. You might be able to find a weather station online, maybe on the Wonderground website or on the WOW website, which gives you a value that's close enough to where you are that you can use it. Luckily, we don't have to use Campbell-Stokes sunshine recorders anymore to record how light it is, and that's all done digitally these days. Here again, I've got a very simple light meter that's recording the light levels here in Salford Keys today. And that's something you might like to use if you're looking at vegetation growth maybe and seeing how light levels vary within a woodland, or all sorts of things that you might like to take the light levels into account for. So this one is just telling me how light it is here and now. Again, you can get simple little USB data recorders which will log light levels over a period of time if that's what you need. Wind speed's a bit trickier. There are lots of different ways that you can measure it, and anemometers for measuring wind speed come in a lot of different varieties. Whichever type you're using, wind speed is always best measured as high as you can reach. So to use an anemometer, you're going to want to hold it high up because the wind speed is going to be greater further from the ground where the friction's less. This is probably the most common type with a propeller in it. The problem with propeller anemometers is that you have to point them into the wind to get an accurate measurement. And when the wind's gusty or when the wind's very light, it can actually be quite hard to judge where the wind's coming from. So propeller type anemometers Yes, they can be cheaper, but they can be quite difficult to use. Cup type anemometers are much easier to use because it doesn't matter which way you hold them, they're always going to record the wind speed. So they're much easier to use, but they can be more expensive, and also they're very delicate because the cups are balanced on a small pin, and as soon as something bends that pin, even just grabbing this anemometer would break it. You can get ones that just fit into a smartphone. You can just hold it into the wind and it'll give you a fairly accurate reading. The only thing about these smartphone anemometers is that they can be less accurate at low wind speeds, so they're only really designed to measure faster wind speeds, maybe not over land, maybe over the sea for sailors and things like that. So if you're just wanting small scale variations in wind speed close to buildings, maybe they might not be the kind of anemometer that you're going to want to use. My top tip for measuring wind speed is to use bubbles. Bubbles will give you a very visual and accurate representation of where the wind's going, and you can blow some bubbles, see where they travel, maybe measure out 5 meters in the direction that they're going and time how long the bubbles tend to travel that distance, and then you're going to be able to get some estimate for what the wind speed is. It's not particularly accurate, but as long as you're using the same measurement, same way of measuring it in different places, you're going to get at least a comparison of how the wind speed is changing. You can get small handheld weather stations that will record pretty much all the weather variables that I've spoken about so far. They'll record temperature, wind speed, humidity, pressure, they'll record everything. And they can come together with tripods and wind vanes to keep them pointing into the wind so that you're getting accurate wind measurements from them. They're very nice, they'll log the data which you can then download to a computer and get a recording of the weather and how it's changed over a longer period of time. If you want to include weather measurements in your independent investigation and your school doesn't maybe have the instruments that you need to record the measurements that you want to include, then the Royal Meteorological Society can loan you instruments free of charge. So just contact the Royal Meteorological Society via metlink.org, which is our website, and we might be able to lend you some instruments for the duration of your independent investigation.